Okay, now that we know how to plot straight lines, how to calculate gradients and y-intercepts from graphs and also from practical problems, we can finally give a straight line a very formal and mathematical description. So this is what we call the gradient-intercept form of a straight line. Basically, we have y, it is expressed in terms of x, and we have the gradient m, which is basically the coefficient that multiplies x. And we have the y-intercept b, which is the point at which the line cuts the y-axis. So to give you a few examples, we can have a situation like this one in which we're given y equals to 2x minus 1. And we want to find out what the gradient and y-intercepts are. So in this case, it's very obvious. We already know that the gradient is going to be 2. And the y-intercept b is going to be equal to minus 1. And that's it. But some other times it's not going to be as obvious because they will give you an equation of a line which is not in the form that you wanted, where you can directly retrieve the information about the gradient and the y-intercept. So in that case, we actually need to rearrange it for y to see what those values are. So in this case, we can subtract x from both sides. So that's going to be 2y equals to minus x plus 6. And now we can divide both sides by 2, so that means that y is going to be equal to minus 1 over 2x, and then this is going to be plus 3. So in this case, we can see that the gradient is going to be equal to minus half, and then for the actual y-intercept b, we're going to have 3. Alright, so now we're going to do some more examples with this so that you understand the whole concept of it. So we're going to start with question A here, and we're going to rearrange that equation. So basically we can write this as y equals to minus x plus 4. Therefore the gradient is going to be equal to minus 1 and the y-intercept equals to 4. For this one here, we can rearrange again. So let's start with 3y equals to minus 2x plus 6. And now we're going to divide both sides by 3, so y is equal to minus 2 and 3x plus 6 divided by 3 is 2. So the gradient is going to be minus 2 divided by 3, and the y-intercept is going to be 2. Now for this one, we start off with 4y equals to minus x, and then y is going to be minus 1 over 4x. So in this case, it turns out that the y-intercept is 0 because there's essentially no constant term here. So the gradient is going to be minus 1 divided by 4. And then the y-intercept is simply going to be 0. And for this one, we're going to do the same. So let's subtract x from both sides. So that's minus 4y equals to minus 3x plus 12. We're going to multiply both sides by minus 1, so that becomes 4y equals to 3x minus 12. And then we're going to have y equals to 3 on 4x minus 12 divided by 4, which is 3. So the gradient is 3 divided by 4, and the y-intercept is minus 3. Okay, so that's all done. And the really useful thing about this is that simply by knowing the gradient and the y-intercept, we can figure out all the information we need about that straight line, so we can actually plot it straight away just with this information. Now in the next question, what we're going to do is something quite similar, but we're going to actually be determining if the following point, so the set of coordinates, lies on each of these straight lines. So let's start with the first one. Now the quickest way to check if a point lies on a particular straight line or any function or any curve is just to plug in the values and see if you get the same. So in this case, this corresponds to the y coordinate. So if we plug a value of 1 into x, we should get y equals to 2. So in this case, if we put 1 into x, we get 2. Therefore, it lies on that line. For this one, we're going to have minus 2 times 1, which is minus 2, plus 4 is going to be equal to 2. so it does lie on that line as well. For this one we have y equals to minus 1 plus 3 equals to 2, so it does lie on that one. And the final one here is going to be equal to minus half, so that's just going to be minus half plus half, and this is actually equal to 0, so it does not lie on this particular one here. And we're going to be doing a lot of this stuff in the next video as well, when we're checking whether a point lies on that line, because that's how we can actually find the equation of the line when we're not given this extra information.